Hi, everybody. My name is Tim. I am an iOS engineer and I work at Twitch on the iPhone and iPad app. And today I'm going to talk a little bit about an intro to design systems. So this is really just like a high-level introduction to kind of what these things are. And so they were all on the same page. I wanted to start out with a definition. So design system is a single source of truth which groups all the elements, which can be components, but also other things that will allow the teams to design and develop a product. So this is both design and engineering. I will be focusing more on the engineering part because that's what I'm more familiar with. But if there's any questions regarding the design side, I will try to answer those. So I wanted to start out with a little bit of an analogy. So imagine you have a drawer full of Lego bricks, and somebody, a designer, for example, comes to you and says, "Hey, I want you to build this house, and I've made this neat little mock-up for you." So you can look at this and see, okay, so there's some bricks that I can really easily tell that are used in this mock-up. So you go to your drawer, you pull out a few bricks, and maybe you're able to build this house with that. I'm actually not quite sure because you don't see the back of it, so there may be some differences. You will figure this out as you build it, right? And there's mostly standard bricks in this house, but there's some special ones, the windows and the door, for example, and they're represented as hand-drawn here. So maybe your drawer did not offer you these special components or special bricks, so you might have to build them with the standard ones. So when I talk about standard bricks or standard components, what I'm actually really talking about is UIKit and Apple's design resources. So when I say UIKit, I kind of mean like the iOS components. So even if you're using Swift UI, under the hood, these will still be the same components. So this can be keyboards, navigation bars, alerts, modals, status bars, a lot of different things. We've probably all dabbled with it. And depending on your app size, this is maybe all you need. This is what sets you up pretty well, and you can build amazing apps with all of this. But sometimes we reach the limits of UIKit and their components, and Apple does this as well. So there's custom UI, right? So if we look at the Maps app, for example, there's a lot of standard stuff, but there's also this bottom sheet, for example, that pulls up, and we have this tab bar at the bottom that horizontally scrolls, both of which are not part of the UIKit component library. If we look at the App Store, I think we're all familiar with the Today tab, which has a lot of custom transitions and animations. But I've chosen the Apps tab here because even in this one, there's some custom stuff. For example, the Get button has some transforms and animations, and it's used really extensively throughout the App Store. So that is definitely a standard component within the App Store app. And we have iBooks, which, as you can tell, uses a custom font. It's a serif font. I believe it's called New York, and it is not part of the standard UIKit text styles. So if you want to support dynamic font sizing, for example, you might have to do some custom work around this. And then there's third-party apps like the Twitch app, for example. It also uses a lot of standard UIKit stuff like the tab bar at the bottom and the navigation title and bar at the top. But in between, there's a lot of custom stuff going on. So we have this carousel, for example, where you can swipe through live streams. We have these labels that are overlaid on the thumbnail that have padding and a background. We have these tags below the video. These are actually buttons that you can tap on to find similar live streams. And some other things that are not standard in UIKit. So in order to support this, meaning in order to stay within a standard within your app, we have this design system. And today I'll be talking about the design system at Twitch. This is not in any means the best design system. It is not the only design system that is out there. It's just one of many. And I want to give you an insight into how we think about our design system when we both design and develop our apps. So first off, I want to start with principles. And the first principle we have is margin. So I took this screenshot again to illustrate this a little bit. And our margins are generally multiples of 4. So at the left-hand side, you can see them defined. Standard margin being 8. And these allow you to put all the components that you have on a 4x4 grid. So within the components, but also the components to each other are aligned on this grid. It also allows you to add and multiply. So for example, if you have twice a standard margin, well, that makes a wide margin. If you add tight and standard together, you get a medium margin. So no matter how you use them, they will always be on this 4x4 grid. For illustration purposes, I've overlaid a grid here. It's actually kind of hard because the lines themselves have a thickness, so it is not 100% accurate, and it's actually an 8x8 grid, but you can kind of see that the things on the left-hand side line up pretty well. For example, the thumbnail at the bottom and the purple tags and the profile picture and the discover title. And the same goes for the right-hand side as well, where we also have this 8 standard margin between the right-hand side of the phone and the purple buttons as well, and the icons at the top. And this is a great way to abstract magic numbers as well. So of course you could just go through your code, and with your layout constraints, you could just always say +8 or +4. But what happens if you want to change these? Are you going to go through your whole code base and manually edit them or do a refactor? So if you're hiding these actual numbers behind constants, you're able to use them without having to think about the actual value behind it. And this also allows us to approximate values in mock. So if we get a mock from Sketch or Figma, within Twitch we use Figma. So if there's a margin that may be 8 or 9, I can be pretty sure that this is going to be a standard margin, and I will just apply that in my layout code. And it also allows you to use these same defined constants across platforms. Our app is on iPhone and iPad, and we use the same values behind it. But maybe you're also on macOS, and the standard margin on macOS may be 16 because you have larger screens. So you could still use the same layout code, but the numbers behind it may actually differ. Next up, I want to look at text styles. So within the Twitch app, we have 12 custom text styles. We're also using a custom font, and we have pretty much everything covered. Most of these sizes come in both semi-bold and regular. And again, we have them defined in code so that when we're getting a design and the design is using a title or a headline font, we can really easily translate this to code. And as a developer, you just have to apply this named font and you don't have to worry about anything else. And you also get dynamic text sizing for free, even with these custom fonts that are backing it. Next up, another very important principle is colors. So around 2 years, almost 2 years ago, Twitch rebranded. So we went from a darker purple to a new Twitch purple, internally called ultraviolet. Slightly different hex color, and a lot of our components have this as a tint color, buttons and many other things. So of course you don't want to go through the whole code base again and change these values. So we have a color named Twitch Purple, and as we did our rebranding, we simply could change out the hex value, and most of our components automatically updated with this. But Twitch is a lot more than just purple. We have a whole color palette. These are mainly static colors, which come in a core, an accent, and a muted region. But in addition to static colors, we also have a whole bunch of themed colors. You will see that a lot of Twitch users really like their dark mode. So we have this whole color hierarchy where certain backgrounds work best with certain text colors, and our designers, there's a whole bunch of color theory behind it that I'm not going to go into in too much detail. But basically, a lot of components will have an associated background color and a text color, and they have active states or hover states. And those ensure that we have enough contrast. So for people with who are maybe colorblind, they will still be able to read this with enough contrast. So moving away from the color theory and the design guidelines here a little bit, I wanted to spend a little bit more time talking about the theming from a code perspective. So we've been supporting theming for a while now, and the minimum target currently is iOS 12. So we have to support custom theming. We can't rely on the iOS theme. So the way we do this is we have a protocol, the app theme, which defines all of our colors, and then we have a light theme and a dark theme, which implement these and then reflect this value. We also have a theme manager that handles theme changes and has a current theme property associated with it. And within our view controllers, this is injected, and we can observe theme changes and can then update our labels and components and other things. We don't write this file ourselves. So this is actually all auto-generated. We use a JSON file. That is our source of truth for the colors. And this one is shared across web, iOS, and Android. And from this JSON file, we then create Kotlin files, we create Swift files, and we create CSS files so that we can automatically generate the protocol, we can automatically generate the light theme and the dark theme, and also our static colors, which is what essentially backs this. For simplicity, I've just called the UI color black and white, but in truth, this will be like a Twitch black or a Twitch, hinted gray or something like that, that is backing these themed color tokens. And then if you're lucky enough and only support iOS 13 and higher, you may be able to use this dynamic color property wrapper, which allows you to just have a single theme file. And you may not even need a theme manager because as the trait collection or the user interface style changes, iOS will automatically call this closure and will update the colors within your components or within your text. All right. Another principle that we use within the app is corner radiuses. This, again, is more just to abstract magic numbers. And this can be used by many components to define their radius or take this in as a property so that you can style them. And then we have icons. So UIKit actually now has a big library of icons through SF symbols. And these are really great if you're an independent developer and you don't have the resources. We have a lot of custom icons, as you can see in the middle, for a whole bunch of our features. And we want to make sure that these icons are the same across web, Android, and iOS. So we don't use SF symbols out of that reason. So we have these custom icons. They're designed by our core UI team. And we then ingest these as PDF files within our asset catalog. And then again, we're auto-generating this file. We're kind of allergic to string APIs, especially when it comes to UI image, because we have been burned when we had our redesign. We had a lot of assets that we switched out. And there's no compile time safety around this. So there was actually some crashes or some dormant assets that were laying around. So we're now using this as a build phase. I've put a QR code at the bottom. We're actually able to open source this. So we're creating this in a build phase, and Xcode is pretty smart about looking if the asset catalog changed or what the input and output files are. And then we also get auto-completion when we code something. And again, these are matching the naming of our Figma files. So if we're looking for an icon, we can find it pretty easily. Another principle we have is elevation, or a fancy name for shadows. These are 5 different levels that differentiate in their blur, in their radius, in their spread. And these are all encapsulated into an elevation view. Why are we using a subclass of UI view over just a simple method? This is so that we can also set the shadow path, especially important if you have corner radiuses on your images, or as we do, set this on an AV player that often refreshes. You want to make sure that for performance improvements, you don't want to actually forget to set the shadow path. All right, so these were a whole bunch of principles that we're using to build our primitives. So primitives are simple components within our design system that we use throughout the app. And the first one I want to look at is button. So this is a standard UIKit button, as we probably all know it. And we're going to transform this into a Twitch-styled button. So first, we're going to apply the text style. We will apply the colors. This is both the background and the text color. We will apply some content insets. And finally, we will apply the corner radius. And again, you could think, okay, this is pretty easy for simple steps. We could, probably write a reusable function that takes, is an extension on UI button, applies these things, and we're done with it, right? But this is just one style. So in addition to our primary style, we also have secondary, destructive, and naked. Naked being the closest to the actual UI kit button. So that's 4 times 4. And then we have this is the normal state, right? And then there's also the disabled state, which again slightly differentiates the styling. And there's the highlighted state when the user presses on the button but hasn't yet lifted their finger. And then since iOS 13.4, we also have hover states through pointer interactions. So we'll add some shadow to it or have this background view that slides behind it, the cursor. So 4 different styles, 4 different states, and then these 4 styling. That is a lot of customization. So this is probably the point where you're saying, okay, this should definitely be a subclass of UI button. And we're not overriding the draw method or anything fancy in it. We're just extending the standard API with the style component and some other things as well. And this then creates this standard button API, which under the hood is just a UI button. So you can still access all the standard APIs like target, add and target, or style some other things. But it also allows you to set this style, this Twitch specific style. The standard is primary, it's the default value. You can also change this after the fact, so you don't actually have to pass it to the initializer if you don't need to. And we have a whole bunch of more primitives. This is just the selection of a few, but I will call them out because they're used over and over. We have a switch, which has a custom tint color. We have these tags, which are interactable, have some state associated with it. We have these overlay labels that are used over the thumbnails. We have custom tabs, which allow you to, there's some animation in that as well, and they allow you to select something. And we often use this if we want to stay within the same screen, but actually differentiate the content that is being displayed. We have inputs with a lot of different states associated to it, heavily used throughout sign up and login. We have our avatar view, which is an image view that loads asynchronously, has a border applied to it, which can be the creator color. We have this little live overlay if the creator is live. And we also have some table view cells. They look kind of close to the UIKit ones, but there's some variations to them, especially the font styling and the theming that backs them is custom implemented. And then with these primitives, we can build patterns. So patterns are components that are built using primitives. It's sometimes a little bit hard to differentiate a component from another component, but a pattern really is something that is built up of primitives. And an example of that would be our action sheet. So we have 2 variations of it. We have one with header that has this little close button at the top, and then we have one that has no header and has a cancel button at the bottom. And some different styles associated with it. I won't call out everything in detail, but those are the different variations that you can style these actions. And I want to dive into a little bit of the API here. So we have this header style that can be put into the action sheet. The image and the subtitle are optional as long as you supply a title. That's all you need, and then you will get the close button for free. You can also pass in a custom view. Again, the close button will still remain, or if you don't want a header at all, you can also pass nil or none in this case. You saw we can create sections. This is a standard table view section. Can optionally have a title, and then you pass in these actions in an array. Or if you just want to have one section, there's also a convenience initializer, just takes an array of actions. You don't need to actually create a section in the first place. And then the action itself, again, has 2 different initializers. One is the more standard one where you can set a lot of the properties, style being a custom one where you saw the plain style is the mainly black one. We have a destructive one for actions that delete something or block a user, for example. We also have a disabled one if there's a action that is not available, depending on you have a pending friend request, for example. We have a localized title. We have an accessory, also a custom one, but it can basically be a switch or check mark or the little disclosure indicator, accessibility identifier for UI tests, and then a handler. And the same goes for the Many of these are also available for the custom one. So we have the accessory, the accessibility identifier, and the handler. And then you can pass a custom view if these predefined styles don't fit your need. And you can also pass you should also pass a localized accessibility label, because accessibility is pretty important in this component, so that users with voiceover are still able to understand what this action does and what it describes. And here are some use cases where we're using this sheet. As you can tell, patterns are used in a lot of places, so it's definitely something that is reusable. Another pattern that I wanted to call out are cards, which you probably saw in one of the first screenshots. It's where you have the thumbnail, and you will notice some of the primitives used here, the tag button or the overlay labels, the avatar view. And then this depends if it's a horizontal or vertically scrolling view of cells. And we also have this cell for our games. They have slightly different aspect ratios, which is actually another thing that we abstracted the constants in. I didn't specifically call this out. But yeah, these are just two examples of our patterns. There's many out there, but this is a good overview of what our design system looks like. So to wrap this up, a few takeaways. I wanted to go over the taxonomy again. We have the principles, which are higher level concepts that allow us to build these primitives and principles. So if I say higher level concepts, I guess this comes more from a design world, because in code, you can definitely have a font and nothing else. Like the font can exist by itself. But I guess if you are in Figma or design world, a font really can't exist without a label, right? You need text in order to display it. So that's why this is more thought of as a concept rather than like an actual tangible thing. And then primitives are the building blocks of the design system. They're small, single purpose, buttons or switches or sliders, toggles, etc. And these can be used to build our larger components. And then the patterns that are composed of two or more primitives, and they're widely used throughout the app, more than once for sure. So I also wanted to talk a little bit about pitfalls. I think I've mentioned a few of these, but what we've encountered so far is it's sometimes hard to discover these components. So if we add a new component to our design system within our iOS app, that's a special framework, how do engineers actually discover this? And there's a few things we've done around this. We now have a dedicated documentation site, which is cross-linked from our design guidelines. So if you get a design and you want to find out more about this component and how it works and what the properties are, you can go there and you can click on the link and you can see the actual code documentation. So this is generated from our API, from our doc strings. And Swift UI, we can also do a lot where we actually can render a preview of all the, so even though we're using UIKit, we can use Swift UI to render a preview of these components with all their different states and all their different properties applied to it. So a developer can go in and see if this fits their use case, if their use case is covered for their feature. Another one is communication breakdown. This can both be within the teams or across design and engineering. If things, for example, aren't, let's say there's a property that the design team knows about, but it's not implemented in the code base, then there probably is somewhere a communication breakdown where this wasn't communicated, that this was added or modified or moved, for example. Kind of touched on this with the discoverability, but it's really important that these components have API documentation so that you know what these properties do. And oftentimes this also helps you to understand how they're defined and what these standard properties are. True opinionated components is also another thing. So a good example that I call out here is the UI segmented control in UIKit, for example, is not really flexible. So in order to modify this or customize this view, you would have to go into the subview hierarchy of it, which you probably should never do because that may break over OS updates, or if this is internally, there's no guarantee that the hierarchy will not suddenly change in a pull request. So really making it so that the components are customizable and that you can basically change every property of it, especially when it comes to colors or sizing of them. Um, touch a little bit of this with the communication breakdown, but a mismatch between naming, especially for design and code. So if I think a good example is if a designer talks about a toggle, an iOS engineer might think, oh, that's a switch. Probably that's a good or is one communication that or naming difference that both know about. But if this goes into really custom components and you don't suddenly know, like for example, what is a call out and what is a notice? Like they seem similar, but what are the actual differences? So if we ensure that they're named the same way, then we can be sure that we're talking about the same thing and that they behave the same way. And then also, if you don't follow these things, this will probably lead to many one-offs causing UI fragmentation. So if even though we have very similar use cases, developers always implement their custom implementation of it because maybe the one that's already available doesn't 100% fit their needs. Then they may look slightly different, they may behave slightly different, and that will cause fragmentation both in your UI but also in your user experience. So what should you do? Well, you should build components that are reusable for many use cases. You should have well-documented API for your properties that you're exposing. They should be built with accessibility in mind so that the components out of the box support voiceover and voice control and dynamic font sizing, etc. You should aim to cover 80 to 90% of requirements. So let me explain this a little bit. You're probably not going to cover 100% with your component, especially if you're in a large app and a large team. But as long as you cover like 90%, that will already be very helpful for most engineers. And then the last 10%, you should make sure that you offer a customization. And that is actually the last guideline. So these go hand in hand. Strive to cover 90% of the standard use cases, but then also allow customization for the rest of the 10%, for example. So I want to go into a quick review of the design system itself. So we've talked about standardizing components and principles. Design system is a single source of truth for both design and code. It definitely accelerates feature development because we can share these components and don't have to build them for each and every feature ourselves. And UI updates can be performed at an app level. So I talked a lot about this a little bit with our redesign, but that also means, if components slightly change between OS updates or, designers often like to update their components as well, then we can perform this in one place and it will be reflected everywhere. For example, the action sheet, if we decide to change something about it, it will be reflected in all of the use cases. And with that, thank you all so much for your attention. You can find me on Twitter or GitHub at Tim Roesner.